Hello and welcome to Redis DEVcember. Today is December the 8th and Justin is going to be joining me to talk about Redis sets. But before we do that, really quickly, I wanted to show you where you can go to get all of the Redis DEVcember information and catch up with our previous streams. So we have a website here on Redis Developer. It's developer.redis.com/devcember. Tells you everything about what we're doing, and what's starting to fill up really nicely here now is this list of previous streams. So up to today, and then tomorrow we'll have a new topic that we'll announce tomorrow. So that'll be a nice surprise, and we're going to do it at a slightly different time. So we've been doing these recently in the evenings UTC, as Justin lives in California, and then he's able to join us. And tomorrow we'll be back more towards the European morning at 10 o'clock UTC. So I will be presenting tomorrow, and we will reveal tomorrow's topic a little closer to the time. So we're trying to keep these streams nice and short and succinct, so I won't talk for much longer. I'm joined today by Justin Castilla from Oakland, California, who's one of our developer advocates.
Good morning. Good morning. Good evening. Good afternoon.
Yeah, it's my evening. I'm in the UK, Justin's morning. So without further ado, Justin's here to talk to us about Redis sets, which is one of the built-in data types in Redis. And I will get out of the way and allow him to do that. Thanks, Justin.
All right. Thank you, Simon. All right. So sets, if you were tuning in yesterday, or if you were watching video or day 5, I believe, when I was covering Big O notation, I covered sets a little bit. So if you want to get even more information on sets as far as performance, check that video. But for today, we're going to cover nothing but sets. So sets are a unique collection of elements. Now, instead of elements, we're going to call them members from here on out. And it's not a list. That's one thing that we need to keep in mind. It is a unique collection of members in that there are no repetitions or duplicates of the members. So let's start, as always, my nice little, very simple slides here. So on my left, I actually have a set, and you'll notice that all of these numbers are unique. There are no duplicates. Now on my right, that is not a set because you see that I have a duplicate of red 3 different times. So the data type on the right would be appropriate if it was a list. List, you can have elements of the same value, but with a set, you can't. And that actually is really, really important. It's great for deduplication. So you can add multiple items to the set, and if there's a duplicate, it will just be denied. So you only have unique values within your set. Also, if you have just unique values that you want to put in your set by nature, such as a user, it's going online, or a piece of inventory for your commerce. It is a unique item, especially if it's a piece of art or one-off item. So how do I add a member to a set? Well, you use the sadd command. Here, I'm using sadd, the name of the key space, which is set:numbers. And then the value, I'm going to add 17 to this set. And yeah, thank you, Simon. This, again, is highlighted in our Redis IO commands list, which is fantastic. It gives you a nice article on what the data type command is, its performance, when it was released, what version, and some pretty simple examples to get you started. So definitely check those out. All right, so if I want to actually know how many members are in my set, I use the scard command. That's the cardinality of the set, and that just gives me the number of unique members within my set. If I enter it here, I'll see that I have 9 unique members. Now, if I just want to check within my set if something exists, I can use the sIsMember command. Now, this is good when you have a very large amount of elements in your set and you have no idea and you don't want to actually look through it. This just tells you, which is really nice. So let me see. I'm calling sIsMember set:numbers 14, and it's giving me a 1 for true. Yes, 14 does exist in my set. If I call sIsMember set:numbers 15, It's not going to be in my set, so it's going to give me a 0. So that's good, predictable behavior. And if I want to remove an object or remove a member from my set, I'll call srem, followed by the key, of course, and then the actual member, so 14 in this case, and that will be removed. Cool. So the real fun thing where sets really kind of earn their pay is when we have set operations, where we have multiple different set keys and we have them interact with each other. We ask them questions like, what do you have in common? What do you have in uncommon? So, you know, what's unique to your set compared to this other set? And we have 3 different commands: intersection, union, and difference. I'm going to cover intersection and union because difference is pretty simple, and intersection and union are pretty interesting. So I want to see the intersection of 3 different sets. What do they all share in common? Now, again, one set key, one set object has to have unique members within itself. But it's okay for 2 different keys to share or have the same member within their sets. So I'm looking at A, B, and C, set A, set B, and set C together. I'm calling the sinter command, which is S intersection. And it's going to tell me what member or members are shared or common between those 3 sets. And on the right, you can see this visual here of these 3 circles of the sets. Only 0 is shared between those 3 sets. So it gives me back 0. And if I call set union, this will actually give me all of the members between set A and set B. It's not going to duplicate whatever is shared between the 2. So between A and B, they're actually intersecting 0 and 2. But I'm not going to get 0 and 2 twice. I'm just going to get it once. So this is actually really nice to tell me what all encompasses both set A and set B. Cool? Cool. So this is neat, but let's have a real world example. I'm going to show you what I actually kind of do at home for an example. Boop, there we go. So this is a Redis Insight 2 up and loaded. And I actually am a musician that collects a lot of guitar pedals. Now, guitar pedals are little devices that you put within your audio line between your guitar and your amplifier that colors the sound. It can make it distorted. You can add echoes or reverb. It can sound really pretty. It can sound really nasty, whatever you want. So I have a lot of pedals. I build pedals. I trade pedals, and I'm a good friend. So I loan my pedals out to a lot of my friends whenever they want to give them a try. So I actually have created a little bit of a system on my Redis instance at home to kind of manage my pedals. So as an example, here is one of the pedals I just bought. It is an Earthquaker Devices Hummingbird. It's a tremolo pedal. And there are a couple of different aspects of this pedal that I track within Redis. First of all, I have it in my possession. It's on hand. It's a tremolo pedal, which is a specific type of pedal that makes a sound. Also, it's not battery powered. I have to plug it directly into the wall. So these are the things that I actually want to keep track of. So first I'm going to add with the sadd command to my pedals tremolo set. So I have multiple tremolo pedals. And then I'm going to add EQD for Earthquaker Devices and the Hummingbird. Very pretty name. Okay, there we go. And then I also want to add it, since now it is in my possession, I'm going to add it to my in-stock inventory. sadd pedals on hand. And I'm going to add, again, EQD Hummingbird. Cool. So I now have the Hummingbird on 2 different sets. How is that interesting? Well, I'll show you. Let's continue on with my example. I got back my pedal from my buddy, the Boss Bass Chorus. It's another pedal, and it was on loan, but now it's in my hand. So I'm going to transfer it from a set that was previously on loan to a set that is on hand. So let's first check, did I have this on loan? So pedals on hand. Let's see here, call that boss. They're on loan. It's a boss base chorus. Oh, I actually didn't have it on loan. Bad for me. So I just gave this to my friend. I didn't actually update my system here. So let me add this to pedals : on loan. Oh, I misspelled that actually. Sorry. Live TV, you gotta love it. I actually misspelled on loan. So let me see. Okay, there we go. So S is member, pedals on loan, boss base chorus. This is me saying, hey, do I have this on loan? Does one of my friends actually have this pedal? Since it's giving me a 1, that's a yes. So that's saying, yes, you do actually have that on loan. You shouldn't have that. And if I want to look at all of my pedals on loan, I'll call S members. S members just gives me a visual inspection of all of my pedals that I have, : on loan. And there we go. See, these are all my pedals on loan: Empress Reverb, Proco Rat, Digitech Distortion, Big Muff Bass Pie, Boss Bass Chorus, and the Digitech Obscura. So these are all on loan. So now that I actually have my bass chorus pedal, I want to put this on hand back into my own inventory. So I'm going to do S move, or smooth, as Guy Royce and I like to call it. Smooth will, just like it sounds, move a member from one set to another. As you can see here on my right, on my Redis Insight, smooth source destination member, move a member from one set to another. And you can also see the performance of O of 1. Redis Insight, the new Redis Insight 2 is fantastic. So much information. So I'm going to smooth my pedals on loan, on dash loan, to pedals on dash hand, and the member boss bass chorus. Now this is moving the boss bass chorus member from my on loan set to my on hand set. And there we go, integer 1. Now up here, I can see different sets. So pedal fuzz, pedals that have batteries, pedals on hand, on loan, non-working. So let's look at on loan. And I'll see all the members of my set on the right here. So Digitech Distortion, Digitech Obscura, Big Muff Bass Pie, Empress Reverb. Let me refresh this here. And, oh, let's look at on hand, I'm sorry. Fuzz Factory, Centaur Clone, EQD, Afterneath, Fuzz Face. There we go. Boss Bass Chorus. So now I see it's on hand. It is no longer on loan. Cool. And now, one last thing. I want to see what pedals I have that are fuzz pedals. So let's look at S enter. I want to see all of my fuzz pedals that are battery powered, because let's say I have a show tonight where power is limited and I have to bring my own batteries. Now I'm going to use a fuzz pedal. So let's look at fuzz pedals and battery pedals. There we go. So this is an intersection of fuzz pedals that are battery operated. And so now I have an option between a Big Muff Bass Pie or a Fuzz Factory. Cool. So now I can actually use Redis to maintain my ridiculous collection of guitar pedals. And I can ask it questions like, what do I have right now? You know, maybe that's on hand, and looking at Redis Insight, what do I have that's non-working? Ooh, so I have 3 different pedals that are not working. I have to work on them and fix them up. Do I have them in stock on my own hand? A couple. I need to get those from friends. So yeah, ignoring the interesting color of the members, sets are really important and really, really powerful for creating intersections and unions. So you can tell what you have. This is great for inventory or locations. Like in our RU 101 course, we use Olympics as an example. Like, is this sports arena ADA compliant, or does it have concession stands, things like that? Or is this event, this sporting event, is it going to happen in this sports arena? and is it going to have like one of my favorite, team players or something like that. So sets are very, very important. You will see later on that this kind of like intersection and search does get upgraded by use of Redis search with Redis JSON. And we'll give you some previews into that later on within our DEVcember courses. But yeah, that was Set. It's really cool. There's something bigger than that called a sorted set, where each member has a score and we can keep them sorted. But sets are really cool, very powerful data structure that you can use to really solve a lot of interesting problems that you would never kind of think about until you're faced with them. So if you have any further questions about sets, as always, check out our Redis explainers. Our dev advocate, Andrew, did a great job on covering sets in 2 different videos. Also, we have a lot of great content in RU 101 on the set data type. So yeah, thank you very much. Take it away, Simon.
All right. Thanks very much, Justin. So yeah, that was sets, which is, as Justin says, one of the data types in Redis. We have other sorts of data type that look like a set. So there's a sorted set, which is a way of keeping unique members with a score. So you could do like range queries. People use those to build things like rate limiters and all sorts of things. And then tomorrow with myself, we're going to be looking at something called a Bloom filter, which is fascinating because it's kind of like a set. We can put things in there and it will tell us if things are in there. But it's what's called a probabilistic data structure, which means it's going to lie sometimes. And we'll look at what the advantages of that are in certain situations and why we might want to do that. That's quite a tongue twister. So yeah, that'll be tomorrow at I believe 10 o'clock UTC, so European morning, with myself. Meantime, thanks for joining us. Just a quick reminder that everything that you need to know about DEVcember is here on developer.redis.com/DEVcember. There we go. There's the URL. And we'll keep updating that with topics for each day, as well as a recording of today's live stream will just appear on there as pretty much as soon as YouTube finishes processing it when we're done here. And then also a reminder, if you're interested in doing some like hands-on content related to these topics, we'll have a small challenge for you this weekend, which we'll announce tomorrow. All right. Thanks very much.
Awesome.
That's everything from myself and Justin today. So yeah, we'll see you on the next one. Thanks.
See you tomorrow.